This is a sample of how we would do the chi-squared test in R. We're going to be using the same data that we did in the previous video. I'm actually going to show you both samples and show you how we calculate the statistic. So here we are in R, and basically what I'm going to do is I'm going to create a variable called data, and then I'm going to create a vector, and this vector is going to have the individual numbers that we had from the previous example, which was the number of students registered for the classes. So this is number of students registered for the classes C1, 2, 3, 4, and 5. I'll expand this out a little bit so that we have some room. Okay, make the adjustment here, C2, C3, C4, C5. And you can take a look at the video that we did using the Blackboard so that you can see how this relates. Now this is really simple in R because what we're going to do is we just want to see if these values are equal, if there's an equivalent. So you may have stated that the null hypothesis, which I'll write here, H0, is that P1 equal P2 equal P3 equals P4 equals P5. That was our null hypothesis. Just erase this. Okay, and that our alternative hypothesis, HA, was that P1 was not equal to, which I represent with an exclamation point, equals, because we don't have another, that's the way you really would do it anyway in programming languages, not equal to P3, not equal to P4, and not equal to, oops, sorry, P4 not equal to P5. Okay, so we have our null hypothesis and our alternative hypothesis. And so now what we're going to do is we're going to run a function called chi-sq.test, and we're going to run this on the data variable. So the chi-squared test here is the function that we have, and we're going to run it on the data set called data, which we had up here. We could change this if we wanted to a different variable, which I'm going to show you. We're going to use the different set of data. And again, this is referring to the second set of data that we used to see that, you remember we had rejected the null hypothesis in that case. So when I highlight this row, I'm going to highlight data, move my cursor over to the first line and click run in RStudio. And what this will do is down here on the console, it will register data, and you can see on the right side that it has put all my values into this data variable. See if I can expand this out a little bit for you. You can see 40, 25, 19, 37, 39, which is exactly what we had. Now what I'm going to do is I'm going to run line 6 here. I just move my cursor there and I click run. And you'll see it's given me the chi-squared test for the probabilities. My chi-squared value here is the sample chi-squared. That's 11.125. And that matches the problem, the second problem that we had before. You'll notice that the degrees of freedom is 4. And now it gives us the p-value, 0.02519. Now, before we had said we were comparing the sample to the critical value. And if you recall, the critical value from the table was 9.488, okay, with degrees of freedom 0.4 and alpha 0.05. If you recall that from the second part of the video. Since we're not given, and we didn't give it an alpha, we're trying to figure out, well, how does this work? Well, this works pretty simple because if you look at this p-value represents the probability that we are wrong in our assumption that they are basically not equal. And that the probability of it being equal is actually 0.025, which is less than the alpha of 0.05 that we were looking for. So if you see this p-value being less than the alpha value that you're trying to test, we can reject the null hypothesis. So in this case, if alpha is 0.05, we can reject the null hypothesis, which is exactly what we did in our previous example from the Blackboard. But here's an interesting thing. If our alpha level that we were looking for was at the 0.025 level, this p-value is actually greater than, just slightly, than that alpha 0.025, and therefore we cannot reject the null hypothesis because the p-value is slightly greater than the 0.025 level. So this is the way we would do that. Now we'll take a quick look at the, going back to the first problem in that, from the video, and we have our values of where we had C, And the numbers that we were looking for were 35, 31, 38, 27, and 29. So what we'll do is we'll run that. And so now data is something else. And actually what I should have done was I'm going to go back to the first one, run that, put that back to where it was. We're going to do data 1. I'm just going to give it a whole new variable name. So data 1 now has the new values. Data, I put back to the old values just by clicking on it. Again, how I did that is I just moved the cursor on line 13 and I clicked run, and it gave me the data 1 being 35, 31, 28, 27, 29. I then do the same chi-squared test, chi-sq.test data 1, which will work the chi-squared test on the new numbers. And now you will see here that for data 1, down here on the console side, the chi-squared statistic was 2.5, which is exactly what we got. Degrees of freedom was 4. And our p-value is 0.64. And so what that means is that since we were looking for the alpha 0.05, since the p-value here is greater than 0.05, we cannot reject the null hypothesis. In order to reject the null hypothesis, the p-value must be smaller than. That goes a little bit different from the sample and critical, where before the chi-squared sample had to be greater than the chi-squared critical. Here we're looking at the p-value, the probability. It's actually the reverse, that the p-value needs to be smaller than the alpha value that we were looking at. And so this is how we run this in R.